Well, hello everybody. We're going to today talk about rotation and specifically define what is a radian and why it's useful. So we'll begin. Just a simple definition of rotation. That's how much some object has turned or spun. And rotation has units, just like most quantities we study. The standard unit for rotation is what's called a radian. And you're probably more familiar with degrees or revolutions, which is full turns. Gradients is another old unit, which perhaps one of you might describe for us in detail later this week. But here are the conversions that you can learn and memorize for making conversions. A single revolution is usually referred to as 360 degrees. And that is 2 pi radians, which is, well, 2 times pi, 6.28-ish. So a little more than 6 radians all the way around a circle. And as you can see, that's also equal to 400 grad, or gradients. That would mean that 100 gradients would be equivalent to a right angle, which is equal to 90 degrees. And maybe you've learned in geometry or pre-calc that a 90-degree angle is equal to pi fourths radian. We'll calculate how many radians that is in a little bit. But first of all, a little more formal definition of what a radian is and why it might be useful. A radian is equivalent to the amount of angle or rotation that it would take to travel the equivalent of 1 radius around the circle. So as you can see here, if I were to go 1 radius's length around the outside of the circle, then the amount of angle that I went is equivalent to 1 radian. So on this drawing, I went 2 radii around the outside of the circle, and that's equivalent to 2 radians. If you were to go 3, you'd get almost all the way around. Pi radian is exactly halfway around, and so forth, and keep going all the way around. And it's 2 pi r to go all the way around. You've learned that formula for circumference before, and that's why there are 2 pi, or 6.28 or so radians in a full circle. So, as a little more formal definition, an angle in radians is defined specifically to be the ratio of the distance that you've traveled around the outside divided by the radius. So that's what the little colon in front of an equal sign means, is that it's set this way by definition. Typically, we find a slightly more useful equation to be the distance that something has traveled around the outside, that's the S for position, is equal to the radius times an angle. In common practice, it's easier just to think of this relationship using unit conversion techniques. So let's do a few unit conversions. Why don't we start by answering the question of how many degrees is equal to 1 radian. So to answer a question like that, I'll use a unit conversion technique. I will start with 1 radian. And if we look at our unit conversions, 2 pi radians is equivalent to 360 degrees. So we can write in here 2 pi radians on the bottom and 360 degrees. We'll take 1 radian and multiply it by 360 divided by 2 pi, and when you do this division, you need to be careful that you put the 2 pi in parentheses, or alternatively, you could divide by 2 and then divide by pi. But when we calculate this, we get our answer of roughly 60 degrees, or more equivalent to 57.3 degrees. Or another conversion example we could ask is how many radians is equivalent to a right angle. So looking at the diagram, a right angle would be coming in at little more than 1 radian, a little less than 2 radians, so pretty close to 1.5. Let's do that conversion. We'll start with a right angle of 90 degrees, and then multiply that by the conversion factor of 360 over 2 pi. An equivalent one, which might be easier to use sometimes, is that 180 degrees is equal to pi radians. And so if I write 180 degrees on the bottom, so degrees cancel, and pi radians on top, then you could write this exactly as pi halves radians, and you've probably learned that in geometry. In physics, we tend to be a little bit more practical. We don't care about the exact values of pi over 2. I want to know, is that 1.57 or 1.5, or how did that work? So we'll do pi divided by 2, and that gives us 1.57 radians. So we'll say approximately 1.57. We'll do a little bit more practical examples rather than just converting things. Let's calculate how far I've traveled if I'm on my bike, and I've counted how many times my bike tires have turned, and suppose they went around 103 complete rotations. What is the distance that we traveled? We can use the formula S, which is the distance around the outside, or in this case, the linear distance I traveled, is equivalent to the radius times the amount of rotation that I've completed in radians. I know my rotation in revolutions, 103 complete turns. If I could convert that into radians, then I can use this equation and multiply by the radius, and that will get me a distance. And the truth is, the kind of a shortcut is we don't really need to memorize this equation as long as we do the appropriate unit conversions and take advantage of a useful trick along the way. You can think of this problem as simply a unit conversion. So I'll start with the total distance, that is the total rotation that I've traveled, 103 revolutions. I'd like to convert that into a distance, and the technique to make that happen is to convert our angle into radians and then use the radius as a conversion to get us from an angle into a distance. So let's start by multiplying this by the conversion that 1 revolution is equivalent to 2 pi radians, which I'll abbreviate RAD on purpose. And the next conversion is I'm going to include at this point the radius. I'm going to say the radius is 26 inches per radius. Now you might think I'm getting a little sloppy here. That's a radius and a radian. Those aren't exactly the same thing, but I've abbreviated them the same way. And that is the trick. Because of the definition of radians, 1 radius is equivalent to or 1 radian is the amount of rotation it takes to go 1 radius around the circle. So again, by definition, they are essentially equivalent, and this trick of calling it a radian and calling it a radius works. And at this point, I know my distance in inches. I know that that's a pretty, this is going to be a pretty big number, so I'm going to go ahead and convert it all the way into feet. So we'll say there are 12 inches in 1 foot. And if I grab the calculator and calculate 103 times 2 times pi times 26 and divide by 12, we get a total distance of 1,402 feet, or roughly a quarter mile. And here's one more example of a problem that you can try, and maybe you can think about this while you're on the bathroom. This is where most of my good physics comes. Or how many times around the spool does a typical roll of toilet paper go? I don't know for sure the size of the squares of toilet paper or the number of sheets on a roll, but I'm guessing there might be 1,000 4-inch squares of toilet paper on one of these spools, and on average, I'm assuming the radius is about 2.5 inches. At the beginning of the roll, it's wider than that, and at the end of the roll, it's narrower than that. But if we use a typical average radius of 2.5 inches, I think you can answer this. So go ahead and hit pause and see what you can come up with. And when you're ready, we can play and see what you did. So, like we've done before, I'm going to start with the fact that I know, and that is the total length of my roll would be 1,000 times 4 inches, or 4,000 inches. And at this point, I can convert that linear distance. This would technically be the S, if you wanted to think about S equals r theta. And so I will now use the radius fact. That's 1 radius is equivalent to 2.5 inches. And what that also means is that I have traveled 1 radian if I have traveled 2.5 inches around the outside. And so this would convert the distance of 4,000 inches into an angle in radians. And this makes more sense to us, I think, if we convert it into revolutions. So I'll go one more step, and we'll say there are 2 pi radians in 1 revolution. And if we multiply at this point, 4,000 divided by 2.5 divided by 2 divided by pi, which I'll just abbreviate. And we get that it takes roughly 250 times all the way around for 1 spool of toilet paper. So I'll leave that to you guys to confirm. Next time you're sitting down, go ahead and count how many layers there are and see how accurate our information is.